discuss about this emission control as you have seen the subject name. Here in this emission control, we'll discuss few very important things, before going into that, I'll try to classify emission control into two major areas. The one is the before the pipe solution and the end of the pipe solution, right. Before the pipe solution is this, before the pipe solution are before the pipe solutions. This the solutions, the before the pipe solutions are the solutions. Here the solutions means solutions for emission control. Solution before the pipe solutions, the solutions that are implemented before pollution actually takes place. So let me give an example, then it will be clear. Suppose procuring, say that the number one steps, the procuring low sulfur coal, right. Then implementing a non-polluting method, implementing a non-polluting method in the industrial process. Suppose or say for that matter another example that you can think is substitution of a polluting raw material by a non-polluting material, by a non-polluting material. So the three things that we have been talking about is a procuring, say low sulfur coal. So you are in the beginning itself, you are reducing the chances of production of sulfur dioxide during the burning process of coal. Okay, so this is one. This is called the before the pipe solution. This is number one case examples like that we generally try about. Implementing a non-polluting method in the industrial process. Suppose in the process itself there are some methods which are highly polluting in nature. Changing that, implementing a non-polluting method. Like in many cases, like I tell you one thing, one of the reactants, something like cyanides, which were generally being used, are now being replaced by non-polluting methods, particularly for say recovery of gold. So in gold mining recovery, non-cyanidic methods are being implemented in place of cyanidic methods, which itself can reduce the pollution to a great extent. So substitution of a method by a non-polluting method. This is the second option that we can try of. substitution of a polluting raw material by a non-polluting material. Say, just see, it says lead-free petrol. Lead-free petrol. So what we are trying to do is, the petrol we used to have lead in it. Used to have lead in it, which was at times was mixed with the petrol also. There is just to for its fuel efficiency, to improve the fuel efficiency. Now it is being, the process itself has been changed in a matter that we do not require a leaded petrol anymore. We can use lead-free petrol for our own purposes for the same efficiency. Not only that, there are various other kinds of methods are being adopted. It's like something like, you might have heard of hybrid cars. The hybrid cars, there would be, the hybrids are like, one process is basically a fuel burning process, like petrol, using petrol. Another would be by the battery. So a combination of these two. So the battery powered vehicle, battery is semi-battery powered and semi-fuel powered vehicle, a mix of that would be polluting less. So this is the idea. So there are various new kind of fuels are also being applied. So these are called before the pipe solutions. So before the pipe means, the pipe here is the total process, industrial process. So before the process, whatever checks you can do to reduce pollution. This is one of the greatest areas of environmental control today. So before the pollution actually takes place, you try to control the process in a manner that the pollution becomes less, or the process itself is so made that the pollution becomes less. So this is what is the before the pipe solution. End of the pipe solutions are generally end of the pipe solutions are the pollution reduction methods that are used before, that are used after the pollutants have been generated. After the pollutions have been generated. So we have not made any change in the process. Say something like, what you see is something like, say, the one particularly, if you go to any plant like nowadays, if you are just going for say chimney stacks or the smokestacks, smokestacks or chimneys are most visible end of the pipe solutions. End of the pipe solutions. Say is a particularly like that what we have heard of, what we have mostly discussed. Say something like the wetland, pond, then say oxidation pond, trickling filters, then say just try to think of say a chemical precipitation, etc. are called end of the pipe solutions. So, the mostly all this are chemical precipitation. It is also important to say at this point, it is also important to say at this point that the most of in today's world, before the pipe solution, solutions are being more favored than end of the pipe solutions. End of the pipe solution by improving process efficiency, substituting products and processes, etc. So, here you can see now that this is what is that we would see that the preeminence of or the growth of these concepts before the pipe solutions are being more favored than end of the pipe solutions. Okay. Now, having to see that, I think this is understood to you. So, one of this is one process talks about after the pollutants have been generated, how to contain them, how to dispose them, how to reduce their effect. So, okay, but the pollutants have been generated. Another process is before the pollutants are formed. Before the pollutants are formed, the process is so modified or so designed or so altered that the process itself would produce less pollutants by means of the method applied. So, here as such if you are going on to further on this. So, if we just trying to see this is the before the pipe solutions and end of the pipe solutions. So, solutions, this is solutions. We can now subdivide this emission control methods as the gaseous which is generally this is fluidized bed combustion, boilers, FBC boilers, low-NOx combustion, and flue gas desulfurization. Flue gas desulfurization. Okay. And this is about the most prominent methods of mostly dealing with this. And the particulates, in terms of particulates, we generally what we use mostly is the cyclones that is a reverse the typical cyclones that we use, then we use electrostatic precipitators, and we call that this mostly the bag houses. So, if this, let me again further go into that. Emission control, I said then before the pipe solutions and end of the pipe solutions will be not be able to talk about them, because says the scope of the course doesn't belong to that. But as I have said, the basic principles I have already said, how these methods are developed. I have said what are the underlying principles that we have discussed. End of the pipe solutions, we will discuss more clearly on them, more in detail on that. That's gases. For the gases, generally the gases, like as mostly the concerned gases that we would be interested is NOx. Then we would be also be interested at one point in time about CO2. So, fluidized bed combustion, low NOx combustion, flue gas desulfurization. This is flue gas desulfurization. So, these are the three methods: flue gas desulfurization, or we generally call them as scrubbers also. These scrubbers, and in the particulates that I have talked about, say the particulates of PM10, PM5. So, for those particulates, say in a PM10, PM5, this is the particulates that you can use: the cyclones, electrostatic precipitators, and bag houses. Let me just deal with this each of them in some detail, so that you have a general idea about what are the things generally used in terms of air emission control in industries. Mostly what we are discussing is emission control in industries. So, remember this may be quite different than the domestic appliances. In cases in industries, emission control in industries, and further than on this we can discuss on all these aspects with and their useful, how they are used and where they are used. So, the first is fluidized bed combustion. Fluidized bed combustion. Fluidized bed combustion is basically in today's world it is becoming more and more common as such, as a method, as a generation of power generation methods. A number of plants today are for their captive plants, they are using FBCs, fluidized bed combustion method. Here what is done is, generally why it is called fluidized is, the idea is that the time when these coal particles are being burnt, they are in the state of fluidity. The state of fluidity means they would be suspended, mostly suspended in air, very fine particles, mostly suspended in air, so that their surface area increases. As their surface area increases, they are more efficiently burnt, and the output of heat energy is certainly more than standard combustion methods, and as a result of which, when they are mostly remained suspended. How this generally is done is, very fine coal particles are remained suspended on a stream of air. So, as just as if thinking of a train of air, and on top of that the coal particles would be would remain in suspension, or would be in the state of flow. So, this is how this has got derived the name fluidized bed combustion. So, understandably, as you can see, particularly when all surfaces of the coal particles are exposed to combustion, the thermal efficiency would improve. This is particularly important for coals having high inert material. Mostly in all countries throughout the world, the quality of the minerals are going down, because the best quality minerals perhaps we have already mined or we have already worked on. So, as the quality is deteriorating, this kind of methods where the energy efficiency is more than the standard methods are now being brought in. And in this, the fluidized based combustion method, what we generally try to do is basically in FBC boiler, this is FBC boiler. In FBC boiler, crushed coal mixed with limestone is held in suspension, fluidized by fast rising air injected from the bottom of the bed. Fluidized by fast rising air injected from the bottom of the bed. Sulfur dioxide formed during combustion react with limestone to form solid calcium sulfate. Which falls at the bottom and is removed. So you can see this, mostly if you just observe the point of burning in a fluidized based combustion. This is where this very finely ground coals would remain be suspended. They would be occasionally fed into the boiler, and the air that would enter through this, would keep them suspended. And so you can see this. So this is the air that would go in. So finally, there would be a trap here. I think I have not drawn that. So just trying to think of a trap where the calcium sulfate that I have said, the calcium sulfate and all other things would be, all other inert material would be deposited. And the other air, the air outlet, the after combustion, the air containing carbon dioxide, NOx, etc. will be emitted outside through the boiler. So here itself, so this is air, this is coal, this is air. and this is the fluidized bed. So, this should be, if you just observe, this is the FB fluidized bed. This is the fluidized bed. This will be the fluidized bed that we are generally we would be in a position to observe. So, here as you can see now, this is what is a conceptually a fluidized bed. I mean, this is good enough just to say, how this is, as we know, to remove sulfur dioxide. The sulfur dioxide, we generally make them to react with limestone to form solid calcium sulfate, which falls at the bottom and is removed. So, this is one way of reducing sulfur dioxide from the flue gas, So, this is about, another is low NOx. One important thing about low NOx combustion. Low NOx combustion. So, as you know, since air is entered into zone of combustion, NOx will be formed by the oxidation is only possible because of the heat generated, combustion heat aided by heat of combustion. Since air is entered into the zone of combustion, NOx will be formed by the oxidation of nitrogen in the air as well as nitrogen in the fuel, that is primarily liquid fuel. Particularly, there are, perhaps some of you might be knowing that, there are the power plants which are also, run by the fuel, either by gases or by the liquid LNGs that, liquefied natural gases. So, these are also one way of generating electricity. Not only that, in many coal power plants also, whenever there is, the energy drop, along with coal, diesel is entered into the blast furnace. This is known as surcharge, oil surcharge. So, this oil actually supplements the loss of heat due to poor quality of coal. So, is particularly for the boiler to maintain a particular pressure of water, vaporized vapor in a particular pressure, so that the turbines can turn. It has to have a very high amount of steam to be generated. So, this high amount of steam to be generated would be only possible when there is a steady supply of heat. If the supply of heat goes down, the air pressure would not be, the vapor pressure would not be sufficient to run the turbine. So, this is with this, sometimes the liquid fuel surcharge is generally given to that. So, here, so this can produce NOx, One technique for this, known as low excess air, low excess air one technique known as low excess air is a process where just sufficient amount of air is supplied to reduce the formation of NOx. However, nitrogen that will come out during the dissociation of we leave the furnace as N2 only as against NOx. However, N2 will come out during the dissociation of fuel. We leave the furnace as N2 only. So N2 would not be changed. N2 would be, the air would be supplied in such a quantity so that the combustion takes place, but yet N2 does not get oxidized into NOx, and leave the furnace as N2 as against NOx in other processes. Okay, this is called one technique, that is called low excess air. Another technique uses stages of combustion, where another technique uses stages of combustion one stage to release N2 only, and another stage where only the fuel gets combusted. Well, the fuel gets combusted. Like what we do, is basically what we do generally in the caking of coal. This is basically what we generally try to do. Is if you just heat the coal, say at 70 degrees centigrade or 80 degrees centigrade, what do you expect? You only expect the volatile matter to go. So the fixed carbon does not get oxidized till at that temperature. So after that, the fixed carbon would be put into another chamber where it would be then oxidized. So in the first place, similar case is done here. The fuel in the nitrogen locked in the fuel would be dissociated from the fuel itself in the first stage, where it would leave as N2, nitrogen only. But then the oxygen this would be all in a reduced environment where there would be little oxygen in the first stage. After that, in a completely oxidized state, but since N2 has already left, so there will be a very little NOx would be formed in the second stage. Okay. So, the release only the stage where only the fuel gets combusted. So, the one stage is there, you can see is in reduced environment, and another stage where only the fuel gets combusted. So, this is low NOx combustion process, where how we can reduce the generation of NOx. Another method that we generally use is a introductory part of that, flue gas desulfurization. These are scrubbers. These are also known as scrubbers. We will not discuss about the dry scrubbers, we will just discuss about the wet scrubbers. Wet scrubbers, most commonly used wet scrubbers are like this. Most commonly used wet scrubbers, the is here it's the same, the finely pulverized limestone plus inert siliceous this is special clay. This is basically a special clay where purely finely pulverized limestone plus inert siliceous compounds are with water is sprayed to the stream of flue gas containing sulfur dioxide. So, the particularly in the a sulfite, remember a sulfite precipitate in the form of paste due to water. Since we have added water, so it forms a paste. Otherwise, basically, as you can see, it would be a sulfide that would be formed. The sulfide is CaSO3. This CaSO3 in the presence of water would form a paste, which is collected in a trap. So, which is collected in a trap. The usual reaction is CO3 plus SO2 plus 2H2O and forming COSO3 H2O plus CO2 plus CO2. So, here you can see that this is what I said as the paste, which is forms in the paste which is collected in a trap. So, what is generally done is, as you can see, so if you can say a stream of fluid gas, a stream of flue gas says containing the flue gases, a stream of flue gases, then this would be at a particular portion here, at a particular place, this would be here. So, you can say this would be there we would offer you see the vapor here, and we would inject CO3, that is say powdered lime, so this the air passes like this, but at the same time you will find, say if it is being sent like this, the paste settling on top. So this is what is the CaSO3 H2O paste. This is also just a very simple schematic diagram, how it works. So the water, this particular air, as you can see, is relatively free of SO2. Here is the free of SO2. All right. Now, having to say this, then we can further go on to say about this thing that we have already discussed about this flue gas desulfurization. We would now discuss about something about this particulate control. The particulate control. Particulate control. This is a typical schematic of a cyclone. I think you must be knowing what is a cyclone by now. So let me just give you a small example how it works. Say typically a small cyclone would be like this. Here so not exactly of this dimension, it should be about this, but nonetheless you can very well understand here. There are two aspects of it. One is this is the inlet, and this is how this air would actually revolve. It would work as a centrifuge, and on top of that this is how the air flow would be inside, and here also there would be another air flow that would be generated. This is something like quite similar to an exhaust fan that would be formed here. So here, as you can see, this gas inlet, these are the gas inlets. So this gas, there would be this is one aspect of this is how this gas should be. This is a centrifugal force. As you can see, if the air is thrust into this, so it would form a centrifugal force. This centrifugal force would be, another counter centrifugal force would be given, which is just on the other side, which would be in this place here. So this would be in two different directions. So as a result of that, it would form a cyclone, which is this cyclone, and as a result of that, this as the centrifugal forces, as you know, the heavier particles would go across towards the sides. So the heavier particles would be clouding here, and they would come, impinge on the outer surfaces. Many of them would begin to go down like this, and this is where they would mostly come out. So the heavier particles, so the lighter fractions go. So the heavier particles, heavy particulates, heavy and large diameter particulates, and the small particulates, the small diameter particulates would leave. Small particulates would leave. Okay, understood? So it's just this is how this air would be taken. Two streams of air that I have said, two streams of air that would take place, and as a result of which this would form, the air would be, the lighter fractions would be taken out through the top, and the heavier bottom fractions would be taken from the bottom. Okay. Now, having to say that, that's the basic principle is, just to explain this, as the flue gas spins in the cylindrical shell, centrifugal force causes the particles to collide with outer walls, that I have said. And by gravity flows downwards. Efficiency 90% of particles that is more than 5 micron size will be cleared. For efficiency decreases with size. efficiency decreases with size. Okay, efficiency. The next two you discuss is electrostatic precipitators. Okay, in the next class, just after 5 minutes. All right. See this, the topic is EIA, EMP, and EA. We will come back to that, and before we conclude this, and I'll talk about all of them because these are also very important aspects nowadays. One important thing that is electrostatic precipitators that we have been talking of. To see an electrostatic precipitators, how it looks like is what is the generally. Please take this diagram down. You see, this is what is we generally, in all cases, as you can see, in all cases we have to create a charge, potential difference. Mostly for this one is required for the case of this electrostatic precipitator. And as you can see, what I have, these two are important, right? These two are repeated only on this kind. The dotted portion is only a repeated, only the repetition of these two blocks. What is this says is grounded collector plates. Grounded collector plates. So you have a negatively charged discharge electrodes. This is about, say, this one, this discharge electrodes. These are the electrodes. These are the electrodes that you can see. These are the electrodes, and these are the grounded copper collector plates. Grounded collector plates. So what happens here is, this is just to understand that this is not a single column. There will be multiple columns of this in the electrostatic precipitator. They say there may be, say, about 1,000 such blocks where there will be two grounded blocks insulated by another two grounded blocks, and in between there will be three or four positively negatively charged discharge electrodes, and the potential difference, as you can see, can rise up to 100,000 volts. 100,000 volts. So the heavily charged electric grounded collector plates would be used, through which the air would be passed. So through which the air would be passed. So you can see the movement of air would be from here before they are allowed to operate. For most of the industries, particularly any large industries where there would be some kind of production, some kind of manufacturing, there is mandatory now to have environmental impact assessment to be carried out. Environmental impact assessment has to be carried out so as to get certification to carry on with the manufacturing or production job. Now, what is this? Environmental impact assessment deals with qualitative and quantitative estimation of likely changes in the environment if a production or manufacturing manufacturing work is carried out in a site. In today by Government of India, GOI, Government of India orders, EIA is mandatory for all large projects or large projects if it is producing water of a very poor quality, it would has to say that I am going to bring down the say BOD, say the BOD from 10,000 milligram per liter to 1000 milligram per liter. That has to mention in the EMP itself, and then finally the EMP has to be implemented. EMP is a standard regular day-to-day exercise that the mine generally carries out. Okay. And the final the topic that we of the course is environmental audit. Environmental audit. Environmental audit, or also known as EA, that is environmental audit, in a plant to internally assess. This environmental audit may not be a statutory requirement. It is not necessary. It is not necessary that it has to be a statutory audit. Environmental audit is generally carried out in a plant to internally assess and physically verify